I am still on page 204. This is in the margin. It's called the core skill. And I was reading this problem, just looking at it to see how much space I was going to need and all that. And I realized that I don't believe I've ever taken a math test in high school or above that I didn't have to do something similar. So this is truly a core skill. If you have the textbook, you can follow along. If you don't, I just want you to listen to this story or this information. And this is called gather information. That is the core skill. And I'm trying to get my book up here where I can see it. So that's what that is. That sounds like a rat scratching. Okay, when you are asked to identify the graph of a function, one method is to substitute values for x and generate ordered pairs. However, it may require less work to use the function rule to find information about the key features of the graph. Then you can match the key features to the correct graph. Suppose you were given several graphs and asked to identify the graph of f of x equals x squared plus 5x plus 6. So the idea here is that you would be given this function and then a bunch of graphs, and you have to pick the correct graph. Well, I can tell you some key information just by looking at this function. It is a second degree function. And second degree tells me what? Means that we would get a common difference, consecutive difference at the second degree. That means that this is a quadratic function. And it means that I would be looking for the graph of a parabola. And because that is a positive x, the parabola will look like this. Not that, that's a v. There, something like that. It is going to open up it's going to point in the positive direction. So just by looking at that little exponent, I can tell you all this. Usually, that's all you need. You can rule out lots of graphs. For example, if the graph went this way, you could rule that out. That would be a negative x squared. If it went this way, that's not x squared at all. That's x to the first power. If it went this way, that's x to the third power. So you would have lots of choices of graphs, but you can eliminate them just by knowing what we just talked over. But let's go ahead and do what they're teaching me to do here. And to do that, I need to find my intercepts. Okay, so to do that, we're going to have to use some algebra skills. How about that? So the first one, the easiest one to find is the y-intercept, because that's going to be the point at which x is 0. And baby c up here, let me put the formula. Remember, the function for a quadratic, the function rule, is x squared, ax squared, plus bx plus c. And c is the baby c. It's going to be that y-intercept in that point. So c is positive 6. That tells me right there the y-intercept. Excuse me. Okay, let's look for the x-intercepts. And I believe there are 2 of them, but I need to work this formula out to see. We're looking for 2 points on x-intercepts. The y would be 0. So we need to figure out the actual x value of these equations. So I'm going to factor this quadratic equation. And I know that I'll have an x in each of those, and everything's positive So 2 times 3 would give me the 6, and then 2 plus 3 would give me the 5. So those look like the two binomials that need to be there. And then we just need to solve these binomials. So we're going to say x plus 2 is 0, because remember the y value is 0. And then minus 2, minus 2. So x becomes negative 2. That'll be one of the intercepts. And then you just need to do that again using this equation of x plus 3 is 0, and minus 3 minus 3, x is negative 3. So that is the other x-intercept. So I have found those values using algebra. Now we can graph this thing. Let's go ahead and sketch a graph of this picture. So I'm going to sketch myself a coordinate plane. I know that it needs to go up to at least 6 in the y direction because that's the intercept. So I'm going to take it a little higher than that. Let's go to maybe 8 in the y direction. And I did it again. I'm getting just a hair off that axis, and it's graphing it that way. Okay, so 0, 6, that's going to be 0, 1, 2, 3, 4, 5, 6 here. But now before we get excited and draw the parabola, we need to put in those x-intercepts as well. So at negative 2, 0, we have an x-intercept. And at negative 3, 0, we have an x-intercept. So this is looking very weird. Would you agree? I don't immediately see how this equation is going to look on a graph. I do know that my values are good. Everything is correct, in other words. So what's the deal here? Well, before I graph it for you, I want to show you a really neat internet tool. So I'm going to go to my internet, and this is called, well, let me clear up some bandwidth and see if that'll help. It's not helping, so let me try again. The address is mathportal.org, organization. So when you go to mathportal.org, you get all these free math tools. Online calculators, math formulas, there are even math lessons and math tests. This is a free resource. It's really cool. But I want to go to the online calculator, and I want to look for quadratic equation. And I want to do the quadratic equation solver. This is the coolest thing. When I was in college, I had a calculator that I carried around. The thing cost about $200. The TIs, I'm sure they still use them. But it would do this for me. Now you can do it online, and it's way cool. Okay, we're going to input our equation. So remember, we had a positive x squared. You have to give it a coefficient. So 1x squared plus 5x. So I'm just typing in the coefficients. Plus, here's baby c, and that was 6. So I just got that out of the book, and I typed it in there. And then I'm going to tell it to solve. Actually, I'm not sure this is what I want to do because I want to see the graph. All right, there it tells us the x-intercepts that we found. It should tell us the there's baby c. I want to see the graph, and I'm not sure that it's going to show me that. It goes through all the different, that's not what I'm looking for. But this is still a cool thing. It will solve it for you if you have access to a calculator. So let me go back to the home page. I'll try anyway. I want to graph a quadratic equation. For some reason, it doesn't want to go back. It just wants me to refresh. So that's okay. We can do that. Solving with steps. Let's try the quadratic plotter. So y was 1x squared plus 5x plus 6. And here we go. I want to draw the graph, find the xy intercepts. Now let me remind you, to do this, I went over here to the margin right here. Quadratic equation, quadratic plotter. And then I'm going to tell it to draw the graph. And sure enough, there are my x-intercepts again. There's the y-intercept. And look at this. Okay, this is showing me part of that graph. It's showing me the interval that's climbing. It's showing me the increasing interval. So you see that it does dip just below the x-axis, and it crosses those two x-intercepts, and then it comes up here and crosses the y. So if I go back to our graph, we're going to do the same thing. I'm going to try. So we're going to let this parabola come down just a hair below those two, and then back up here. That'll work. I can make this work. Let it cross those 2 points. Well, I said it would. Dad burn it. It may not work. I may have to freehand. I'm going to have to freehand. All right, so here we go. It won't be pretty, but you'll get the idea. So we're going to let that parabola come down this way, just a hair below, and then back up. So something like that. It is opening upward, as we knew it would. But given those intercepts, I can tell you exactly where it crosses the axes and how it interacts with that graph, coordinate plane. Okay, there's another example on this core skill. What key features might you use to identify the graph of 4x plus 2y is 12? So let's think about this one for just a minute. I can tell you it's not quadratic because the x is to the first power. In other words, there's an imaginary ghost 1 sitting there. I can also tell you that this is in standard form, and I really want it to be in slope-intercept form if I'm going to try to graph it. So let's do that first. Y equals mx plus b. And we've already got our y in the right spot. I need to get that 2 away from it. Let me just do it this way. The y is okay. And baby b is okay. We've got it where it needs to be. But that 4x needs to move. So I'm going to subtract it from this side and subtract it over here and cancel. So I'm left with 2y is negative 4x plus 12. But then I still have that 2 sitting there. Remember, we just want a y. Now we've got the 4x in the right place and the positive 12. It's that 2 that needs to move. So I'm going to divide it here and divide it with all the terms here. So y equals negative 2x plus 6. So I can tell you that this is a linear equation. It is not a quadratic. It's a straight line. It has a negative slope. I can even tell you what that slope is. M is negative 2 or negative 2 over 1, rise over run. And the y-intercept is 0, positive 6. So with that information, you and I can graph this equation. Let's go ahead and sketch a coordinate plane. Again, I need a y-intercept of 6, so let's make the graph tall enough. When I was in school, I would watch my teacher's graph, and it just amazed me that they always knew just how tall to make the graph. And that's what they were doing. They were calculating the y-intercept, sometimes mentally, and they knew that that's the point that they needed to draw to. So it was pretty cool when I realized, hey, I can do that too. All right. I should have gone a little bit higher, so let me just make that just a hair higher. But there's the y-intercept of 0, 6. Okay, now given that the slope is negative 2 over 1, we can draw that using rise over run. So you are going to, let me think, I'm going to start here. Fall 2 and run 1 and put a point. Fall 2, run 1 and put a point. Fall 2, run 1, and there's the x-intercept. That's nice to know, that it intersects x at 3, 0. Okay, let's put in 1 back the other way just to get a starting point. So we're running 1, rising 2. I'm doing the opposite because I'm on the other side of the intercept. That's close enough. I need to move this out of the way so that I can draw the graph. And here it comes. Here comes the function. It's going to go through all of those points, making the diagonal of the stairs. And that is your linear graph. Okay. So that's just a little bit more practice, not only with graphing, but with finding the intercepts and thinking about different types of equations. I really, really like that problem. It's good stuff.